Hello students, now in this video lecture we are going to discuss the new module, that is other materials and material selection. So before going to start the processes, first we'll discuss about the ceramics. So basically ceramic is an organic and non-metallic material. It is commonly electrical and thermal insulator. So you are familiar what is meant by insulator. No heat conduction, no electric current flows through it. It is brittle, means it is hard because of more carbon percentage, and it is composed of more than one elements. Okay, it is strong in compression and weak in tension. In the last module I told you, generally the brittle materials are strong in compression and they are weak in tension. It can withstand chemical erosion in acidic environments. It can withstand at very high temperatures between 1000 to 1600 degrees Celsius. They may be semi-transparent and transparent. Example is glass. See, there are two categories: traditional ceramic material and modern ceramic materials. So under the traditional ceramic material category we consider kaolinite, okay, aluminum oxide, glass, okay, these are the bricks, tiles, these are the recent ceramic materials. Modern ceramic materials are also known as advanced ceramic materials, which include silicon carbide and tungsten carbide, silicon nitride, etc. Structure, see, basically it contains the metal and non-metals. So here in the structure, sodium is considered as the metal and chlorine is considered as the non-metal. You just see how the bonds are made between the metal and the non-metal. So dark atom is nothing but the sodium atom, it is positively charged, and these hollow atoms, these are the chlorine atoms which are negatively charged. So this is the structure of the ceramics. Now classification of the ceramics: glasses, optical, composite, reinforced containers; clay products, bricks; refractory, bricks are used as the refractory materials because they can withstand at very high temperatures and therefore they are used in furnaces; abrasives, sandpaper cutting, polishing, etc. cermets, composite structural; advanced ceramics, engine rotor valves, bearings, etc. Now glasses, basically it is a uniform amorphous material. Say amorphous means it is non-crystalline material. Already I told you in module number 1 about the crystalline and non-crystalline materials or solids. The solidification takes place without crystallization. It is hard, brittle, transparent, solid material. Silica based glass material used, which contains 70% of SO2, sulfur dioxide. Now clay. Traditional ceramic raw material is clay, kaolinite, in which water is the initial binder. Okay. It is mixed with ceramic powder, that is silica, to get the uniform mixture. It is used to produce bricks in the construction work. Refractory materials. These materials can withstand at high temperatures without affecting their strength. Main property of the refractory material is they can withstand at high temperatures. They are made of carbides of silicon, oxides of magnesium, calcium, zirconium, etc. Abrasives. So the best example of the abrasives are grinding wheels. Okay. So abrasive materials are silicon carbide, that is SiC, and Al2O3. They provide hard toughness. Now we will discuss about the advanced ceramics, silicon carbide. It is advanced ceramic material. It has highest corrosion resistance of all advanced ceramic materials. They will not be corroded even in acidic or in other environments. It retains its strength above 1400 degrees Celsius. See, generally the material at high temperature they lose their strength, but these advanced ceramic materials, that is silicon carbide, they retain their strength above 1400 degrees Celsius. It possesses best wear and thermal shock resistance. Examples are nozzles, pump parts, etc. Silicon nitride. It shows the highest thermal shock resistance properties. It shows low density, high strength, good resistance to corrosion and fracture toughness. Examples: burner nozzles, aerospace and automotive engine components. Next, zirconium. It has highest strength and toughness at room temperature among all the ceramic materials. This is the important property of the zirconium. Examples: knives, scissors, bearing sleeves, valves, etc. Alumina. It is also most widely used advanced ceramic material. It shows good wear resistance, corrosive resistance and strength. It has high dielectrical properties which are useful in electronic components. For example, semiconductor materials. Sapphire, it shows superior mechanical properties. They show chemical stability with high transmission. Example is blue light emitting diodes. Microwave plasma tubes for high temperature equipment. Tungsten carbide, it is hard, tough and high melting temperature ceramic material. It is used in the manufacture of cutting tools. Now after that, as per the syllabus, now we have to discuss the mechanical properties, optical properties, thermal properties, electrical properties and nuclear properties. That is the behavior of the material, ceramics. Now first, thermal properties or thermal behavior. High capacity is the important capacity, thermal expansion, high thermal coefficient expansion, very low thermal conductivity. It is used in space shuttle. C means even at very high temperature they will not expand, they will not change their size and shape. The outer portion is covered with ceramic tiles from high purity amorphous silica fibers. Okay, the thickness of the tiles varies from 0.5 to 3.5 inches. Fire clay bricks can withstand temperature between 1000 to 1600 degrees Celsius. Now optical properties or optical behavior. These are the materials through which the light of different wavelength can pass. Okay, means all the wavelength light can pass through these materials. They are transparent glasses which are used for making windows, lenses, filters, cook waves, etc. Semiconducting materials such as gallium arsenide, okay, which are used in lasers and LEDs, light emitting diodes. Optical ceramic fibers are used in cable, television signals, telephone. See, telephone cables, okay, then cable, television cables, these are made of optical fiber. Mechanical properties or mechanical behavior. They have low tensile strength and high toughness. So I told you, generally 90% brittle materials, they are weak in tension and they are strong in compression. They generally fail due to stress concentration or presence of cracks. Stress concentration means because of presence of sharp corners, okay, or cracks. So especially in that region more stress is concentrated. So what happens when we apply the load on the material, sometimes because of more stress in that localized region, the material may fail. They show high compressive strength, they show low fracture strength and they undergo brittle failure. Values of Young's modulus varies from 7 into 10 raised to 10 to 40 into 10 raised to 10 Newton per meter square. So what is Young's modulus? Within the elastic limit, it is a ratio of stress divided by strength. That means stress is directly proportional to strain. It means Hooke's law is obeyed. Nowadays, advanced ceramic materials are used to make components of automobile engines, armor of military vehicles, and aircraft structures. Titanium carbide is also used. Al2O3 means aluminum oxide, silicon carbide. They are used as abrasive materials for grinding and polishing. Grinding wheels are generally made of these materials. Now, electrical behavior or electrical properties. Ceramics are often used for electrical insulation. Some ceramics are used as semiconductors, that is negative temperature coefficient and positive temperature coefficient resistors. Resistors are made of ceramics. Most of the ceramics have dielectric constant value up to 100 and they have low dielectric losses. Certain ceramics show piezoelectric properties. What is piezoelectric property? See, when we apply the force, so force is a mechanical quantity, that is the input, and accordingly we get the output in terms of electrical signal, maybe voltage or current. So that is the that is the piezoelectric property. Okay, nuclear properties. These are used in the generation of nuclear power and disposal of radioactive nuclear wastes. Urania and plutonia are used for nuclear fuel applications because they possess very high melting point, that is 2800 degrees Celsius. They have excellent resistance to radiation damage. Okay, the fabrication cost is relatively low and have low thermal conductivity. Okay, applications, traditional uses, bricks, tiles, cement, chimneys, plaster, glasses, etc. Automotive, brake discs, particular filter, water, fuel pump components, wall components. Aerospace, ceramic engine, airframes, missiles, nose, cones, space shuttle tiles, etc. Electronics, capacitors, insulators, semiconductors, dielectrics. Okay. So in the next module, we will going to discuss processing of ceramics. Thank you.